We're going to be looking at integration with u substitution, but this time is going to be for definite integrals, meaning we have a lower and upper bound. And pretty much what the main easiest way to do this, the trick would be after you use u substitution, you do not want to have to switch back to x and integrate with the lower bounds a and b. Instead, we're going to redefine a and b in terms of our u substitution and integrate with those bounds. So let's look at an example. Okay, here we have the function tangent x times secant x squared, and we want to take the integral from 0 to pi over 4. And again, we see that we're going to use u substitution. I already see that tangent could be my u because the derivative of tangent is secant squared, right? So I go ahead and I rewrite that. Secant squareds cancel out. And I'm left with u du. But we do not want to integrate from 0 to pi over 4, or I don't want to go back and change tangent x. But before I do that, we want to integrate. But we want to now integrate with our new bounds, right? So first thing I want to do is I want to change our new bounds. So to get the new bounds, for u, we're going to plug in pi over 4 into our tangent and see what do we get for a u. So what is tangent of pi over 4? Tangent of 45 degrees is just y over x, and we know that the pi over 4 gives us radical 2 over 2. So this is going to be 1, all right? So when x is pi over 4, our u is going to be equal to 1. So now I change that upper limit. And then I do the same. They want us to do when x is equal to 0, what is our u value? So when x is equal to 0, what is tangent of 0? Okay, what is tangent of 0? And tangent of 0 is 0. Okay, so u is equal to 0. Now, I have, again, the upper and lower bounds for integrating u. And this is going to make it a lot easier. Instead of switching back to x, tangent x, and using pi over 4 and 0, we're going to integrate from 0 to 1 for u. So let's take the integral of u, and that gives me u squared over 2 again. And we're going to evaluate from 1 to 0. And when I do this, we just end up getting 1/2 minus 0, and our answer is just going to be 1/2. Okay? So again, biggest thing to point out, make sure that you are integrating with respect to with respect to your new function, and also its new upper and lower bounds. Okay? That's for you. So just keep that in mind. That would be the easiest way. Let's look at another example. Okay, you're kind of wondering, what do I do with this function? Well, we have sine 2 theta and cosine to the of 2 theta to the 3rd power. So we want to look at this function and say, okay, what should be my u substitution? And because sine 2 theta is in the numerator, we know if we take the derivative of cosine 2 theta, okay, if we take the derivative of cosine 2 theta, then we should have a sine in the denominator to cancel out that numerator one. So by doing this, I end up getting du is equal to negative sine 2 theta times 2. Remember, you have to keep changing that. And yes, I know my thetas look like 6's, but those are thetas. I'll try to do a little better with that. Okay. D theta. All right. So we have this. So I replace it. I substitute. I said I was going to have cosine, right? Cosine 2 theta is my u. So this should be u to the third power. And du, or d theta, right? We want to replace d theta, is going to be d theta is equal to du over negative 2 sine 2 theta. So replace d theta with du over negative 2 sine 2 theta. And I see that the 2 thetas cancel out. And now I'm left with negative 1/2. Take out the negative 1/2, and we're going to be left with u to the negative third du. But we're still missing our upper and lower bounds, our new upper and lower bounds. And again, so if x is equal to 0, what is u going to be equal to? Okay, what is u going to be equal to? So if I plug in 0 here, what is cosine of 0? And the answer is 1, right? Cosine of 0, that's your angle. And we know that cosine is the x value on the unit circle, so it's just 1. And what about when x is equal to pi over 6 or 30 degrees, right? What's cosine of pi over 6? And in this case, when we plug in cosine of pi over 6 times 2, though, right? So you get 2 theta. So this actually becomes cosine of pi over 3. So I would be using this triangle instead. And we know this is going to be radical 3 over 2, and this is going to be 1/2. So our new u is going to be 1. Okay, now we have our upper bounds. We're saying that when x is 0, you go to 1, and when x is pi over 6, you go to 1/2. But now look at how the lower bound is greater than the upper bound. So we want to switch that because we want to go from left to right, not from right to left. So we're going to switch the upper and lower bounds, and we're going to take that property that when we switch that is going to be the negative integral. So now it's just going to be 1/2 because negative and a negative makes it positive. So now we could integrate u to the negative third power du from 1/2 to 1. And I'll save the work for you guys. So if you want to pause the video, try to work it out. And hopefully you get your answer of 3/4. Okay, and there's other examples that you guys will have on your notes. But pretty much that's this unit 6.7 is integration by use substitution for indefinite integrals and definite integrals.